This is the updated Arduino code for the MediBox. 3 new libraries have been added: servo.h to handle servo motor functions, pubsubclient.h to handle MQTT, and Arduino JSON.h to handle JSON and serialization. Analog out of the LDR is attached to the GPIO 32 pin, and the servo motor is attached to the pin 33. New objects have been declared for the servo and MQTT client. New 3 global variables have been declared for the LDR and the servo. This is the subscriber topic, and this is the publisher topic for the MQTT. Setup MQ function has been added to the setup function. This if condition calls the connect to broker function if got disconnected from the broker, and the send data function is also included in the loop function. These are the functions we use to handle tasks like timekeeping, updating, setting and ringing alarms, handling the display, reading sensors, etc. This new check light function is added to obtain the light intensity data from the LDR module. The 12-bit ADC in the ESP reads up to 4096 values, and the map function maps these values between 0 and 100 for easier handling. The luminosity function converts the voltage values to the respective luminous values. The window function controls the sliding shaded window. It turns the servo motor to an angle calculated by this equation. The user can change the CF value or the controlling factor between 0 and 1. This determines how much freedom is given to the window. Inside the setup MQT function, the MQTT server is set to the Mosquito broker, and the callback function is set. Connect to broker function establishes the connection between the broker and the device. Receive callback function is called whenever a message is received and extracts necessary data from the payload. Send data function is for publishing the data to the broker. This uses Arduino JSON library to create a JSON file that is suitable to send over MQTT. This is the node red flow. This is the MQTT in node. It is subscribed to the topic MMT data. This JSON node converts the payload to a JSON object if it's not already. This function node is to extract the temperature data from the payload. This is the temperature gauge for displaying the temperature value. Similarly, these function nodes named humidity, light, and lux extract data from the payload and deliver to the gauges. A line chart is used to graph the luminosity values. These function nodes named alarm 1 and alarm 2 extract the hour and minute values of the alarms and convert them to strings to be delivered to the text nodes. This slider enables the user to adjust the controlling factor for the shaded window, and its output is fed into the MQTT out node and published under the topic MMT command. This is the node red dashboard. There are 3 gauges for displaying the temperature, humidity, and light intensity values, and 1 line chart for the luminosity value. This slider is for adjusting the controlling factor for the shaded window, and here the user can see the scheduled alarms. We can see the temperature and humidity values change according to the sensor readings, and when the readings are out of the desired range, a visual and oral feedback is given. The light intensity gauge changes according to the LDR readings, and the luminosity graph displays the change in luminosity over a certain period of time. Here, it is measured over 2 minutes for the demonstration. The servo motor rotates its arm according to the LDR readings, thus controlling the window. The degree of freedom of this movement can be adjusted using this controlling factor slider. Scheduled alarms can be seen over here. The slight delays in the feedback are due to various delay functions included in the code and the linear flow of execution. This can be improved by implementing multitasking methods like RTOS.